again, it's Cliff here. It's 2017. Happy New Year to you all. I've been in the hills for a few days, off the radar, and I'm just back now and catching up again. It's good to be back in the workshop again. So I'm going to do a little bit more on RapidTurn. This is episode 11. We're going to be doing some machining between centres of a finished precision machining of acetal. So it's been roughed out, the stresses have relaxed over time, and now it can be finished machined. It has to be held very lightly because it's fragile material, unlike metal, and I'm going to be testing the RapidTurn for repeatability and accuracy, but with acetal, because it's so flexible and difficult to mic really accurately, it won't be a high-end test of accuracy. You'll see in the clips to follow that it's looking promising, but I've yet to do some really high precision work which will test its accuracy and repeatability to a high end. But this is just the work that, as it comes in, the commercial work that comes in, and I'm able to test it up to a certain level so far. Alright, I'll stop rambling on and get on. Okay, so for this next job I needed to put my 4-inch 3-jaw chuck back on the arbor. I only have the one arbor at the moment, as discussed, and some of you will have noticed in a previous video that I've machined the location spigot off the arbor, so it's free to float. So just nip the screws up, really just finger tight, and then put a dowel or something in the chuck, tighten it up on your marked scroll pinion, wind it with the dial indicator on the top to the maximum high position, tap it again to its maximum high position, tap it. I'm not tapping it very hard. Now you can see that was 2 iterations of adjustment, and now it's true. Well, I've got the camera in my way, but it's true to within, how about a micron, maybe 2 microns, which is far more accurate than you'd get via a fitted locating spigot and trying to reproduce all the variables. So that took, you know, even with filming, it took less than half a minute to actually make that adjustment. And the other concern some of you might have is, oh well, that's fine, but I keep kicking the camera. Sorry about that. But what about it coming loose? You know, you've just got the friction of that flange if you're taking big cuts. Well, it's a big diameter flange, and you're right on the outside diameter with the screws. It's the same as holding a vise down on a milling machine table. A frictional large surface area pinched with a bolt has very good holding power. I've been using this process for many decades on big lathe chucks, and I've never had it shift. Of course, I can't guarantee your safety, and there may be some application one day where it would shift. So always you've got to take care. But I personally have never had it move. Precision machining with acetal is quite a delicate business, and obviously it's a lot less rigid than metal, and it has a much more thermal expansion as well. So you've got to hold it with a very light touch if you're going to do precision work. So here I'm just setting the 3-jaw on the outside diameter, pushing it into the stop, backing off the diameter so I can just rotate it, but it's located by the 3 jaws. Then I'm coming in with the center till I can just feel a little bit of pressure on the stop when I'm rotating it, just a few grams, just enough to turn the rotating center. Then just nip up the chuck. So now the part is held very lightly, but because there's a center there, it's quite stable and secure. Famous last words. way you're holding the part without compressing it or flexing it, and so you're machining it much more accurately. So I've made quite a few score of these now, and I'm getting pretty consistent results. They are varying very slightly, but that may be just the variation in the acetal. This is not a test of a high precision test for RapidTurn. If it was in metal, I'd be able to define just how accurate it is, obviously much more easily, but it's certainly very close. I'm getting the parts within 1/100th of a millimeter, and usually within 1/2 of a millimeter, so that's about 1/4 of a thou variation, and that could be the thermal expansion and the variables of the acetal. So it's certainly good for quite precision work. I haven't yet ascertained whether its RapidTurn is good for high precision work, but it's looking promising. You remember a few videos ago I was talking about the center height of the tailstock is so important in order to get a parallel part, and I left a little bit of metal on the subplate here, just a couple of thou. I'm going to turn the long part between centers. I turned it parallel to within 1/100th of a millimeter, which amazed me. That was really just luck. And now I've turned this little short part in acetal, and it's tapered. And I thought, well, that's a bit strange. Haven't quite worked out why that is. But anyway, it just occurred to me, well, hold on a minute, you don't really have to worry about the height of the tailstock and exact parallelness, because we can just make an adjustment to the code. You know, you've got a diameter and a diameter at the other end, so you just change the code for a destination diameter to be slightly smaller or larger than the starting diameter, and it'll just generate a straight taper. And so really easy way to correct for that. You know, particularly if you're doing a production run of multiple parts, then it's only a few seconds work to make a change, and then it affects the whole run. But it wouldn't be so good for one-off jobbing work. In that situation, it'd be nice to have the tailstock center on the right height. But for the type of production work that I'm intending to do, I can make those corrections to the code quite easily. So that's brilliant. We're just going over editing the code just very quickly. So you can use the conversational to produce a basic bit of code and then just edit it really easily, because lathe code is very simple, particularly this type of simple work. So I had about a 2 thou taper on the part when I took the first cut, so I just entered the diameter 13.86, and then that's the starting point, and then going to Z minus 80.5 and a destination of 13.8, so that's 6/100th smaller, 6/100th of a millimeter smaller. So over that length it's just slowly producing that taper, which is offsetting the error with the tailstock position. So that's so handy, you don't even have to bother about trying to fine-tune the tailstock. You just tweak your code until you get it right. And then if I do this job again and it's different, well, I can just go in and say, alright, that number now needs to be changed by a couple of hundredths or whatever. But it's a pretty simple way of correcting errors, especially if you're doing a production run of multiple parts. Then the time spent doing it is tiny. Here's a little clip running the part showing you the graphics. They're really lovely graphics in PathPilot, aren't they? Just so clear. Turning between centers, think carefully about whether or not the Tormach tailstock will suit your needs. If you're doing this type of work where you need to get in really close with the tool and the tool post, think about the clearance situation above the tool post and the hand wheel, and you might decide that you want to buy a second-hand tailstock, or make one up out of a billet of cast iron or aluminium, so that you can optimize the proportions to suit this type of work. Well, I have to say, RapidTurn really shines for this type of light work. It's accurate and quiet, and has got a nice light feel about it. You can see the little stop there that I mentioned in a recent video. It's really handy for positioning work that's referenced off the back end of it. Well, that was episode 11. Thanks for watching. Cheers. For those of you who are also following me on the impact tolerant touch probes, just a quick update. I'll do a separate video on this shortly, so I'll keep this really brief, but it's going really well. I've made some further refinements. This problem that we've had with RapidTurn spindle bore has really reinforced to me the importance of not rushing a product to market. You have to test it to death and get every single area checked, even before you beta prototype it with the early adopters. And it's so tempting to get a product out there in the market, but you mustn't do that. You must test everything thoroughly over a period of time. I know it's frustrating for everyone, because there's been a lot of interest and support in this, and I thank you for that, but I've really got to be careful here. I want a really good product. Okay, cheers.